Alright guys, let's solve another question from second chapter of the dynamics by Meriam, and we have football tryout that a player runs a 40-yard dash in 4.25 seconds. So the total time that we have in here is 4.25 seconds. And when he reaches his maximum speed at 16-yard mark right here with a constant acceleration, so moving from t0, we can call this point A and this point B. He's gonna have constant acceleration, and after the point A is gonna have constant speed. So these are the givens in the question, and we need to determine his acceleration over the first 16 yards. So the question is asking for the acceleration this distance. We can show it with AA, and we need to find the maximum speed that he reaches. We can call it VA, and the time duration of the acceleration. So we also need to find the time during this acceleration. We're gonna call it TA. And yeah, that's pretty much everything that we need to figure out. So I'm gonna highlight all the values that we need to figure out: the velocity or the maximum velocity at A, the acceleration of the first 16 yards, and also the time that it takes from 0 to A. And once we find that, the time from A to B would be 4.25 minus TA. So let's start the first 16. We can see that the units are in yard, so let's just do the unit conversion for that. We know 1 yard is 3 feet. So from now I'm gonna multiply each of these by 3 to get the distances in feet. So let's move on from, we can call our x-axis here, and this will be our 0. So the first 16 meter, we have a constant acceleration. So the velocity at A is equal to the initial velocity plus the acceleration. We call it AA times TA. So this is going to be 0 because the player starts to run. So the initial velocity is 0. So basically our VA is equal to AA times TA. So basically these are all three unknowns that we are trying to figure out. Another equation that we have in here, we can use our distance equation. We know XA is equal to x0 plus v0 TA time plus 1/2 of AA ts squared. Again, we know initial velocity is 0, so that's going to be 0. Our x0 is 0 because we put our origin right here. So when it reaches to 16 yard at A, so 16 times 3 in order to get it in feet, is equal to 1/2 of AA times TA squared. So that can be written as, so if we just, instead of TA squared, we write down TA times TA, this part is going to be our VA. If we rewrite this equation, VA times TA is equal to 16 times 3 times 2, 6 times 16. That's another equation that we have. And the last equation that we're going to use is that we're going to go in the second half. So, and we write down the equation for the second part, but because the second part we have a constant velocity, so we know in this part the velocity is constant. So we're going to have basically XA plus this time VA, and the T in here would be the time in this part, which is 4.25 minus TA. So I'm going to put that as our T. So 4.25 minus TA. So we have 14 times 3, which is the x at B, 16 plus 24. So 40 minus XA was 16. Again, multiply by 3 to get it in meter. And here we have 4.25 VA minus VATA. So basically I just multiplied this in each of these, and from the previous equation we know this value is 96, so we should be able to find the velocity at point A. So 40 minus 16 times 3, I just bring that one on the left side and factor 3, and the 96 also is going to go to the left side, 4.25 VA. Now let's just calculate this. 14 minus 16 times 3 plus 96 divided by 4.25. So the velocity at point A is going to be 39.5, and the unit would be foot per second. So now we have VA. If we just put VA in the first equation, we're going to find TA. So from this one, TA would be 96 divided by VA, which we found is 39.5. So 96 divided by 39.5, our TA would be 2.43 seconds. So far we found VA, we found TA, and the last one is the acceleration. And for the acceleration, we can just go to this equation right here. Acceleration would be VA over TA. So this is going to be, the TA was 2.43 and the velocity was 39.5, and this is going to be 16.26 foot per second square. And yeah, we found everything. And if you want to find the time in this part from A to B, you basically need to subtract 4.25 by the time that we found in here. And that's going to give us the time for that part. And that would be basically 4.25 minus 2.43, which is going to be 1.82 seconds. And yeah, that's pretty much everything for this one. Hope everything is clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.